earlier?
I don't think so. I think that's, I just don't think we have CT.
Okay.
You have CT?
Not today.
Yeah, what do you mean? You got this study.
All right. Today, we're doing all of chapter 2 today. At the end of today, I'm going to give you the chapter 2 quiz as a take home. Next class will be the chapter 2 test. Chapter 2 is algebra 1. Okay? So, you all know how to do this. We'll refresh memories on how to do these things, but these are all skills you know how to do. Okay? So, when we say something is a solution, what does that mean? Better than it's an answer. An answer doesn't mean that it's correct. Correct. So what does a correct answer mean? What does that do? It satisfies the equation for inequality. Right? If you plug it back in, you get a true statement. You could also, in discussing polynomials, we could use the term root interchangeably with solution. How about a solution set? What does that mean? Guys, solution set?
Like multiple, correct?
Correct. If the answer is more than one number, then you're describing a set of solutions. Where do you almost always get a solution set? Okay, with a quadrant. I was thinking more solving like an inequality, where almost always you have like an infinite number of values that satisfy your inequality. What's an identity?
Is that where like anything works for the solution?
Yeah.
Infinite solution?
Well, not sure. Think back to like trigonometry. What's an identity you know from there? Sine squared. Guys.
Yeah.
Sine squared theta plus cosine squared theta is equal to 1. That's the Pythagorean identity, right? That's what we mean by an identity. That's true for all values of theta. It's okay. What's the difference between like a identity and a formula?
A formula kind of gives you the variables that you like plug the numbers into, but an identity kind of shows you what's equal to something.
So a formula is going to describe the relationship between two or more quantities, right? Like PV equals nRT is a chemistry formula. It's like your ideal gas law formula, right? Describes interaction between pressure, volume, number of molecules, temperature, and pressure. An identity is just a statement that's always true. You can pick random numbers for PV and T and P, but that will not satisfy that equation, right? Okay. So let's get into some examples here. What if I ask you to rearrange an equation? So we have a squared plus b squared equals c squared, and I want you to get b by itself. How do I do that? Okay. So subtract a squared from both sides, then what? Okay, when we square root both sides, what do we get? B equals C minus A is absolutely very wrong. Super wrong.
Equals the square root of C.
Still not correct.
Oh.
Guys, not completely correct.
Plus or minus.
There you go. Great googly moogly, guys. Right? What if we do C? What if we want to solve that one for R? I equals NR over R plus R. What's going to be difficult about that one? If you're looking at part C and you're solving for capital R, what is going to make that problem harder than the first one we did? Guys, capital R is in more than one location, right? So to get R by itself, you are going to have to combine those two R's together at some point into one location, right? Okay. That being said, what should our first step be?
Multiply by R.
I like that. So clear fractions will multiply both sides by cap R plus little r. Now what should you do? What was that, Mia? I would not do that. Because now you're just putting a fraction back. We just got rid of the fraction. Anthony?
Could you move the I?
Emerson, what did you say? Yeah, let's distribute the I. I think that's probably the best next step. Now what?
Divide.
No.
No, I take it back.
Airball.
I take it back.
Airball. Multiply.
No.
Minus what?
I capital R.
Great. Why are you doing that?
Maybe it's the other side.
To get the capital R's on the same side of the equation. It's getting them closer to being together, right, Maren?
Can you factor out the R?
That's what you want to do. I meant this to be little r. Sorry about that, guys. And then we can just
Divide by N. Let's go.
okay, should be able to rearrange formulas using algebra. Okay. Next thing we're going to talk about is linear equation. What's the defining characteristic of a linear equation? It's slope. How do you find slope?
Y2 minus y1 over x2.
Y2 minus y1 over x2 minus x1. Okay. There are three ways to represent the equation of a line, a linear equation. There's the general form. The general form is ax plus by is equal to c, where a, b, and c are all integers. That's typically the most difficult form to get into because you probably have to clear a fraction. There is the slope-intercept form. In our IB textbook, they call slope gradient. Super annoying. Y equals mx plus b. Again, in our textbook, they say plus c. I don't know why. And then there's point slope form. And then they give separate equations for vertical and horizontal lines. I think it's dumb because vertical and horizontal line is just a general form equation with a zero coefficient for A or B, depending on what you got, but there you are. Okay, let's do some examples. Do we need to review how to plot point or to draw a line, to generate points to draw a line? I think we're probably good with that, right? That's usually beaten to death into you in Algebra 1 and earlier. Part A says find the equation of a line that passes through the point 331 and has a gradient of 12. Write the equation in gradient intercept form. What information are we given? A point and a slope. Which formula should I use to start?
Point slope.
Point slope. So y minus y1 equals m times x minus x1. There's an equation for a line. What form does it ask for? Slope intercept, right? So what am I going to do with this? Just going to rearrange it, right? I'll distribute through the 12. And then add over the 31. And we're done, right? Easy peasy. Part B says find the linear equation in C and F, knowing that when C is equal to 10, F is equal to 50, and when C is equal to 100, F is equal to 212. Solve for F in terms of C. So when it says F in terms of C, which one are we saying is the X and which one are we saying is the Y? F in terms of C. C is X. Means F is like our Y. So when I give you that when C is equal to 10, F is equal to 50, what do I really have there? Yeah, I have the point like 1050, right? When we say C, and when C is equal to 100, and F is equal to 212, what is that really? Yeah, that's also a point, 100 comma 212. So what am I really being asked to do? Asked to write the equation for a line given 2 points. Right? What do I do first? Find the slope. Wait a minute. That's 162 over 90. I think, oh, is it the wrong way? So 81 over 45, so 9 over 5. Okay, now what? I have a slope.
Plug the slope and run the points into the point slope line.
Great. Does it matter which point I choose?
No.
No. I'm going to choose to use the first point. Why would I want to choose that one? The numbers are smaller, right? Makes the arithmetic just a little bit easier. Okay, so I have y minus 50 is equal to 9/5 x minus 18. And I add the 50 over. I get that. Oops. Except we should really have called this like F and C, right? Does everybody recognize that formula? What is that?
Y equals mx plus b.
Marin's got it. What is it? For converting between Celsius and Fahrenheit, right? You should have been able to look at the points and know that's what we're building. What point would have given it away? 102.12. What is the significance of the numbers 102.12? Boiling point of water in Celsius and Fahrenheit. If you were observant, you might have caught that. Parallel and perpendicular lines. What can you say about the slopes of parallel lines? They're the same. What can we say about perpendicular lines? They're opposite reciprocal, so. Okay. What's the one exception? What's the one catch for both of these? So we have to be careful about. What? What's the one type of line that's going to fail these tests? If it involves vertical line, right? Vertical lines are parallel, but what are their slopes?
The same. 0.
They're infinite, right? Their slope is undefined. They have no slope. Can't say they're equal if they don't have a slope. What's perpendicular to a vertical line? Horizontal line, right? No slope times 0 slope doesn't equal -1. So you do have to remember that vertical and horizontal lines are perpendicular and vertical lines are parallel. Not usually a big deal to remember that. That's pretty obvious. But should make mention of it. All right. Consider the straight line with the equation y equals 3/5 x plus 2. Find the slope and y-intercept. Oh my God. What is the slope? Oh, brutal. What is the y-intercept?
2.
I usually like to write it as an ordered pair. Since again, the y-intercept is a point. I usually like to write it as a point. I don't think that the IB would be picky enough to mark it down if you wrote it as 2. If they didn't give you specific instructions to write it as a point. Find the equation of a line that passes through the point 1, 5 and is parallel to the given line. So I have a point. What else? What other piece of information do I need in order to write the equation for a line? Slope. How am I going to get that?
The equation.
Because it tells me it's parallel. We know the slope is the same. So it's just a point slope. Did they ask specifically for a way to write our answer here? What should I do then? Leave it the way I got it. No sense in rearranging it if they weren't specific. That's on you. You weren't specific. You didn't ask for it a certain way. I'm going to give it to you the simplest way I can. I'm done. Deal? Part C says, find the equation of a line that passes through the point 1, 5 and is perpendicular to the given line. What do we need to get from this? The slope. What would the slope be? Yes, -5/3 because it's perpendicular. Blake, what's up? I saw your hand up earlier.
Oh, no, I'm just excited I got it right.
Oh, good. Rock on, dude. Everybody good? And again, if they ask for it in a different form, you could rearrange from here, but that's fine. Everybody remember doing this? You do this like 6 times in between middle school to geometry. All right. L is given by the equation 3y plus 2x is equal to 9, and point P has the coordinate 6, -5. Explain why point P is not on L. What was that, Quinn?
Flip the x and y into the equation, and if it doesn't equal 9, then it's not on line L.
100% perfect. That's the best way of doing this. So again, a point is a solution to this linear equation if the point doesn't satisfy the equation and it ain't on the line, done. That's perfect. That's explanation. Notice I didn't have to write any words to do that. Right? That's pretty clean. Part B asks us to find the slope of that line out. What's going to be the easiest way to do that? Get the y by itself. Great. Because in getting the y by itself, what are we actually doing? Well, we're putting it into slope-intercept form, right? So it should be then real easy to pick out that slope. Notice when I divide both sides by 3, I divided everything on the right side by 3, including the 9. So the slope here would be negative 2/3. What's the slope of the line perpendicular to L then? Positive 3/2. And then find the equation of the line perpendicular to L and passing through that point P. Everybody feel pretty good there? Let's write our answer in standard form or general form here, just for kicks. What I want to do that. Remember, we're talking about this form where A, B, and C are integers. Good. So Quinn says let's distribute the 3/2. Oops. Leave an X there. Okay, now what? Let's get the X and Y on the same side and the constant on the other, right? Everybody happy there? Are we in general form yet? No, why not? My coefficients aren't integers. I have a fraction there. How do I take care of that?
Oh, you just multiply everything by the denominator.
Multiply everything through by 2 in this case. Yeah, the denominator. And that's a general form answer. Is that the only way you could write that? No. What if I multiplied through by negative 2 instead? Valid answer. What if I multiplied it through by 6? They'll still all be integers. Be fine. Oh, what a hassle. But you get the idea. Infinitely many solutions to that, right? All right. Next Algebra 1 topic, solving a system of linear equations. The methods that you would have discussed using would have been graphing, probably with your calculator. What are we looking for when we graph a system of linear equations? The intersection. Substitution, elimination, and then technology without graphing. What are we really saying here? What would that technology have been? What would you use on your calculator to solve a system of linear equations if you weren't going to graph them? Yes, a matrix, specifically using the RREF command. Everybody's okay there? When you solve a system of linear equations in 2 variables, you have 3 possible types of solutions. They cross one time, one solution. The 2 lines coincide where they lie on top of each other, where you have infinitely many solutions. Or the 2 lines are parallel, you have no solutions, right? Everybody okay there? If you have more than 2 variables in your linear equations, you get some different types of infinitely many solutions. that's neither here nor there. All right, so blah, 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 those are the situations. Look, here's some pictures. Woo! All right. Do you guys feel okay with graphing the lines on your calculator and finding the intersection? Yeah. Let's review then using the matrix, because that's probably got a little foggy from there, because you probably don't use that all the time. The graphing features, I feel like you probably remember. Okay. So if you have your graphing calculator with you and you'd like to follow along, I invite you to take that out now to do so. The first thing I need to do is I need to look at the equations that I'm given to make sure they are properly formatted for me to translate this into a matrix. My equations need to have the x's lining up vertically, the y's lining up vertically, the equal sign lining up vertically, and the solution lining up vertically. This one is already formatted in the way that I need it to, so I don't have to do any rearrangement. If it wasn't, I'd have to add or subtract things from both sides to get it to a form where everything lined up the way I need it to. Is everybody okay there? Most common mistake students make is they don't do that in the beginning. Okay, what I'm going to do now is I'm going to translate this equation into a matrix. To do that, I'm going to press second and the matrix button. I'm going to go to the edit command, or the edit tab, I should say, and select one of these matrices. I'll say pick matrix A. The equation, or the system I'm looking at, has two equations. So it has two rows, and it has a column for x, a column for y, and a column for the solution. So it has three columns, so I'm building a 2x3 matrix. Remember, it's always rows first, columns second, when describing the dimension of your matrix. And then I just typed in the coefficients from my system as the entries to my matrix. So just reading across 2, 3, 6, because I had 2x, 3y equals 6, and then similarly 2, -1, -10. Any questions as to how I translated this into the calculator? Okay. Once you've typed in this information, we're going to exit out to the main screen, and we're going to retrieve the RREF command from our calculator. That command is located also in the matrix menu, so I'll go back to the matrix menu. But this time we're going to go to the Math tab, and we're going to scroll way down to the bottom and look for that command RREF. Make sure you pick the one with 2 R's. For those of you that are interested in names, this stands for row reduced echelon form. So that's an algorithm programmed into your calculator that's performed on a matrix. Oops, I pressed the wrong thing. So I go into the matrix menu now and I select that matrix A I just made. Close my parenthesis and press enter. This is the output. The way I read this is I translate this back into an equation. Each row represents an equation, so it says 1x plus 0y is equal to -3, or just x is equal to -3. The second row says 0x plus 1y is equal to 4. So in other words, y is equal to 4. You guys remember doing this? Jog your memory a little bit as to where these commands are located and how to get this stuff in there. Everybody happy? I'm not going to bother doing the next one. Substitution, or I'm sorry, elimination. To do elimination here, what do I need to do? What's that? Make numbers the same. So I think being a little bit more specific, I think you know what to do. We want to multiply one or both of these equations by some constant, possibly different constants, so that when I add the two equations together, one of the two variables cancels out. So we could try to cancel out the x's or try to cancel out the y's. Colby, which one would you like to cancel out? The x. Great. What do we need to do that? Multiply the bottom one by 5. Okay. Do we need to do anything to the top one? Close.
Negative.
One of them has to be negative, right? Because 10x plus 10x doesn't give us 0. So one of those should be negative. Which one do you want to make negative? It does not. The top one. Not even a little bit does it matter. Everybody okay? So when I multiply through the negative 2, I get, and then I multiply through the 5, I get this. So when we add down now, 52, and if I divide then by negative 26, I get negative 2. What do I do with the negative 2 now? How do I get the value for x? Plug it back in where? Any equation that has both x and y, right? Does it matter? Not even a little bit. Which one am I going to do? I don't know. Let's do the second one. Done, right? So my solution here would be like 3, negative 2. Is your answer always going to be whole numbers like this? Doesn't need to be, right? Could be fractions or kooky decimals. But typically, what is it going to be? Probably whole numbers, right? If you wanted to check your answer, how would you do that? Plug it back into both. That point has to satisfy both equations. All right. Substitution. Who remembers how to do substitution? Brooks, what do I do?
You get one variable to the side and you plug it all into the next one.
Perfect. Which, looking at these two equations, which variable would you want to get by itself?
Probably the negative y. It's the only one without a number.
Yeah. Good. So let's use this equation and get the y by itself. So I'm going to add y to both sides and then add 9 to both sides. Right, okay there? Again, your enemy here is fractions. So if you can pick a variable to minimize the number of fractions you create when you isolate that variable, that would be the goal. Does it really matter? Are fractions fine? Sure, they're just like a pain in the neck to deal with, and I'd rather not have to deal with them if I don't have to. But it's not wrong. All right, once I have that, as Brooke said, I'm going to plug it into the second equation. Oops, that's a 2. Notice that I have only x's now. So 12x is equal to negative 16. So x is negative 4/3. Everybody okay there? To get the y, what do I do?
Plug it into the same thing with the x. Or you can just plug x
Plug x in where?
back into both equations.
Any equation that has both x and y in it. But to me, my preference would be using this one. Why would I choose to use this one? The y is already by itself, right? I don't really have to do much. So I just get 5 there. So far, so good. You guys all remember doing this junk? Pretty easy. Algebra 1 skills. Probably the hardest thing in this lesson is to cope with a story problem. So let's read this one. When flying in still air, i.e. no head or tail wind, with its propellers rotating at a particular rate, a small airplane has a speed of s kilometers per hour. With the propeller rotating at that same rate, the plane flies 473 kilometers in 2 hours as it flies against a headwind, and 887 kilometers in 3 hours flying with the same wind as a tailwind. Find S and the speed of the wind. My suggestion to deal with problems like this, you want to start by making a name for your variables and identifying what they're representing. What are the two things we're asked to solve for? S and the speed of the wind. So S, we're told, was like the speed of the plane in still conditions. And we need a variable for the speed of the wind. What variable would we want to use here? What letter makes sense? I would pick W, right? Now, speeds are rates, right? Because it's like miles per hour. The quantities you're given are times and distances. What's the relationship between speed, time, and distance? Think back to like middle school science. Distance equals rate times time. Right? Does that sound familiar? Dirt, I think is what they used to call it. So that's going to be how I'm going to write my equations. Everybody agree? Okay. If there's a headwind, is that headwind going to slow you down or speed you up? Slow us down. How much will it slow us down by? The speed of the wind. So, if there's a headwind, be the speed of the plane minus the speed of the wind, that'll be my rate, times time is equal to distance. Everybody agree? So here I have S minus W times 2 is equal to 437. With the tailwind, is the tailwind going to slow you down or speed you up? Speed us up. It's going to push, right? So my rate in that case would be S plus W. Times 3 is equal to 887. And then I'm going to stop from here. Is that okay after we've got this set up? I feel like you guys could solve with substitution, elimination, matrix, graphing, whatever you chose to use there would be fine. The setup is the part that I want to talk about. Is everybody okay? So again, the general idea was figure out what you need to find. Give those variable names. Look at what you're given and find a relationship between the quantities. Right? I had rates, distance, time. The relationship should have been obvious at that point if you really looked at the units. Units are often really, really helpful. Questions on this? Okay. Relations and functions is like the barest of Algebra 1 minimums. I don't know why we're doing this at the second unit or second part of this chapter instead of the first part. Makes not a single lick of sense to me, but this is what they did. What is a relation in mathematics? I'm not talking about your uncle or something.
Like a ratio or
It's a set of ordered pairs. That's all we're really talking about. A mapping diagram is a way to visually represent the relation, where we have like a circle of inputs and a circle of outputs, and we draw arrows from input to output to show how they are paired together. Right? Kind of remember looking at those in your Algebra 1 or 2 classes, probably both. The input is like our domain, that's like our x variable. Our output That's our range, like our y variable. What's the definition of a function? Let me help you. A function is a relation where, nope, more than that.
Each output only has one input.
Okay, that's half of it. There's another qualifier too.
One output.
Okay, so all members of the domain are covered, right? And each member of the domain is paired with exactly one member of the range. So there's two things that we need to worry about, right? Is that a function? I've heard both yes and no's from like the same people. This is a function. All I need to do is look at the domain. Are all the things in the domain going someplace? Are they each going one place? Then it's a function. What if I do that? Is it a function now? No, why not? There's something in the domain that doesn't go anywhere, right? Okay. Is it a function now? No, because I have something in the domain going more than one place. Everybody okay? All right. Function, yes or no? Yes. If I look at the domain, does everything go someplace? Is there one arrow originating from each thing? Yes. It's a function. Does it matter that some of the ranges have more than one thing going to it? Not even a little bit. We don't care about range when we talk about function or not. How about this one? Is this a function? No, why not? 2 and 5 go to more than one place, right? Uh-oh. What if my relation is drawn as a graph? Is that a function? How do you know? I love that. Mia says it passes the vertical line test, right? What is the vertical line test checking for? No, it's if you find two x's that have different y's, right? That's what a vertical line test is checking. So here, no matter what vertical line you draw, it's only going to intersect the graph once. Each x has only one y. How about this one? No, right? For example, that particular x has two y's, not a function. Now, does it matter that I can draw a vertical line where there's only hits it once? Nope. I just need one vertical line that intersects the graph more than once, and it's a fail. Pretty good? Okay. Usually that sticks pretty good. Express the volume of the cube as a function of the length of each side. So I'm asking for a function of volume in terms of E, so I'm going to write V of E equals E cubed, right? The volume formula for a rectangular prism is length times width times height. The length, width, and height of this cube are all E. Express the total surface area S of a cube as a function of the length E of each edge. So here we're writing a function S of E. What is surface area describing?
All the areas
Of the surfaces, right? Okay, how many surfaces does the cube have? 6. Are they all the same or all different? All the same. So we're just going to find the area of one of them and multiply it by 6. Everybody good? What's the area for one face of this cube? E squared. So my surface area is 6. Everybody okay? Can we write a function from a description? Usually that's not too hard. All right, let's do some domains. If I look at this set of ordered pairs, what is the domain going to be for this guy? So first thing you should ask yourself is this list going to be finite or infinite? Finite. So if it's finite, we're just going to use like set brackets and list the finite elements. What are the elements on that list? Does the order that I write them down matter? No. Sets are unordered. Doesn't matter the order that you write them. What does matter, though, is there are no repeated elements in a set. So if this, for example, was not a function, and say like the number 2 was used in 2 different points for the x coordinate, you'd only write it one time. Okay? So volume of a sphere. Is V or R representing the domain? R, good. How can you tell? The V is written by itself. You should assume that's the dependent variable, right? That V depends on R. That's usually the standard. What's the possible values that a sphere's radius can have? Is it finite or infinite? Infinite, so we're going to use like an interval notation to represent that. What are values that R could have? Give me some examples of reasonable values for the radius of the sphere.
1.
Sure. What else? 2. Great. What kind of values can't it have? Negative and 0, right? A sphere with radius 0 would be a point. That's not a 3-dimensional object, right? So it's going to be everything bigger than 0. You guys agree? Fractions are okay, decimals are okay, that's fine. It's just of length. So how do I write that using an interval notation? 0 to positive infinity. Remember, the parenthesis in interval notation means not included in the set. So this is 0 is not included. What do I use if I wanted to include 0? A bracket. Okay. Let's look at C. This function involves the operation of division. How do I know that? There's a fraction bar, right? When we're dividing, what value is the problem? 0. Why? Can't divide by 0, right? So, are there any values for x that give me a 0 denominator? 3. Does everybody see that? Is 2x, or 2 times 3 is minus 6 is 0. So, my domain should include everything except for 3. How do I write that using an interval notation? Well, I go negative infinity to 3, union 3 to positive infinity. Right? That's everything except for 3. Just notice that 3 is not included because it's got a parenthesis on each side. So we have everything below 3 and everything above 3. That's everything except for 3. D. Notice that D includes the operation of square roots. What type of numbers are a problem when we take the square root? Negative. Negatives. Okay. Is 0 okay? Yes, right? The square root of 0 is 0. Would you agree? Okay. So what I need to do is I need to look at the stuff underneath the radical and decide, okay, when is it going to give me a negative value, right? So is it 3 at x equals 3, my radical is 0, right? Do I want everything before 3 or everything after 3? Just let's play a game. If we think after, what's the number after 3? 4. 3 minus 4 is negative 1. And that's a problem for square roots, right? If I take something before 3, let's say 2. 3 minus 2 is 1. Can I square root that? Okay, which side of 3 do I want? Before. Is everybody okay with just like common sensing that? Like we could do it more algebraically, but I think that just like looking at it, thinking about it makes it's usually pretty easy, especially when they're fairly simple.
Does it not include 3?
Oh, thank you, Quinn. Excellent. Yes, should include 3. You need a bracket. Why does it include 3? Because you can take the square root of 0. Everybody good? Okay. Okay. Domain and range for this guy. I'm just going to write the domain, and we'll talk about the range in a second. Because this is basically the same thing as D from above, right? Except, notice this is x minus 2 instead of 2 minus x. Oops. So my interval is going the other direction. Is everything bigger than 2? Or 2 or bigger, I should say. Is that okay? Let's talk about range now. As my number I'm taking the square root of gets bigger and bigger and bigger, the number coming out of the square root continues to get bigger or smaller? Bigger, right? So the smallest y value is going to come from the smallest x value. Everybody agree with that? So if I plug my smallest x value, which is 2, into my function, what do I get? 1 is my y, right? So that'll be the start of my interval. Everybody agree? And are the y's going to keep getting bigger and bigger and bigger as x's keep getting bigger and bigger and bigger? So we're going to positive infinity. Does everybody feel good there? All right. Let's look at this one. Who can tell me the domain here for this? 1. The domain is definitely not 2. Do you mean everything except for 2? Yeah. I think that's probably what you mean. 2 is the number that's important. Okay. What's the range going to be? How many x's are we missing from our domain? Just 1, right? Just everything but 2. How many y's do you think are going to be missing from our range? Probably just 1. It's usually how that works, especially with rational functions. What y value, if we plugged in for h of x, won't we be able to solve for? What number can't, if we wanted to plug that in for h of x and try to solve for x, isn't going to work? Taking so long. 0 is the answer, yes. What would happen if I tried to solve this for 0? I'd multiply both sides by x minus 2, and what's going to happen? 0 equals 1. Right? So 0 is a y coordinate that this function can never take. Is that okay? Now, you might have also recognized this as like a simple rational function. Oops. for a simple rational function, you know that the vertical asymptotes at x equals h and the horizontal asymptotes at y equals k. So the domain should be everything except for the h, which is the 2. And the range should be everything except for 0, because that's like my k. Now, if you remembered that from Algebra 2 or pre-calculus, that would have been super useful. You could absolutely apply that there. All right. Coffee. For domain, what problematic operations are going on in this function? I have division and I have a radical, right? So because I'm dividing, I know that that denominator can't be 0, right? And because I'm taking a radical, I know the stuff under the radical has to be greater than or equal to 0. Everybody agree with the 2 statements I wrote down? If I square both sides of this, I know that 9x squared can't be equal to 0 either. So if it can't be equal to 0, it just must be 9x, or 9 minus x squared has to just be strictly greater than 0. That's good? How do you solve a quadratic inequality? Well, probably the easiest way to do this is to draw the graph. What are the x-intercepts for this graph going to be? Great. What shape is the graph going to be? A downward parabola. How'd you know it was a parabola? X squared. How'd you know it was opening down? Because it's negative. So it's going to look like that, right? Where is this function greater than 0? Negative 3 to positive 3. Everybody good on how I did that? Again, if you didn't know if you couldn't do this by hand, what could you still do? Type that into your calculator and look at the graph, right? You don't need to be able to graph it from just looking at it. You have a calculator. You can use the calculator to look at the graph. That's fine. Is everybody so far so good? Okay. Let's do the range then. This is a lot tougher. What do we know about the... So I'm going to make the same argument I did before. If I plug 0 in for y, that has no solution, right? Should be able to see that real quick now after I pointed it out to you. So I know y, or 0 is not in the range. Now I also want to think about the things that are greater than 0 and less than 0. What kind of number is going to come out of a square root? Positive or negative? Has to be positive, right? No negatives come out of square roots. So if I have positive over positive, can I have any negative y's? So I know 0 is like the bottom, right? My question now is, does this go all the way up to positive infinity, or does this stop? Well, let's think about it. Can I make this y as big as I want? If I pick x to be really, really, really close to 3, say like 2.999999, I square that and subtract it from 9, I'm going to get like 0.000001, right? If I take 1 divided by that, I'm going to get like 100,000, right? Like 1 divided by 0.1 is 10, 1 divided by 0.01 is 100, right? Am I going to be able to make y as big as I want? Right, I just keep picking values closer and closer to either -3 or +3 from the domain. I can make y as big as I need to. So this will go to positive infinity. Again, if you have trouble with that, what can you always do? Graph the function, look at the graph, just look at what the y coordinate is doing. Now this one is tough, because I think because of the calculators, how steep the asymptote gets. This thing has should look like this on your calculator, but I think because of how steep it gets here, it looks like it ends on your calculator. I think they made this problem in particular to make sure you understand and know how to use more than just your calculator to look at it, because the calculator doesn't give you a very accurate picture, unfortunately. All right, last set of stuff. Inverses. What does an inverse do? It undoes a function, right? So if my function sends x to y, my inverse is going to send y back to x. Okay? So if this is my mapping diagram, and I want my inverse, what is my domain going to be in the inverse? The y's. What is the range going to be in the inverse? The x's, right? When we make an inverse, we just swap x and y. Should remember that. Okay? Now I'm going to look, okay, 5 goes to 0, so 0 has to go back to 5. 2 goes to 1, so 1 would send it back to 2. 1 goes to 2, so 2 would send back to 1. 2 goes to 3, so 3 is going to send back to 2. And then 5 goes to 4, so 4 is going to send back to 5. Is everybody okay with what we did there? Notice that the domain for f is the same as the range for y. The range for f is the same as the domain for f inverse, right? Is everybody okay with that? Okay. When does an inverse exist? And when we say exist, mean really when is an inverse a function? So let's think about it this way. For something to be a function, it has to pass a vertical line test, right? So if I take my f and I swap the x and y's, my f looked like this. That's a function, right? Like a parabola. If I swap the x and y's, it's going to look like this. Is that a function? No. So a horizontal line test on f is going to turn into a vertical line test on f inverse, right? So the answer to that is when f is 1 to 1, that means that it passes a horizontal line test. Or in other words, no y coordinate is used more than once. Okay? Does that feel okay? All right. Last example says consider the function g of x yada 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 and its inverse yada yada yada. Confirm that the domain and range for g is this. Okay, you graph and look at the picture, but you can tell this is a simple rational or a rational function where the domain is just going to come from, or the vertical asymptote to the denominator set equal to 0, right? And the horizontal asymptote is going to be, I have to look at the degree of the numerator and the degree of the denominator, because it's a general rational function. They're both degree 1. When the degrees are equal, the horizontal asymptote is leading coefficient over leading coefficient. Mr. Myers, kids, what's the Bobo eats something?
Global bottom ECC.
Yeah, that's it. Boo boo bop bop. You guys know it, so it's fantastic. It works, right? You remembered it? So there's my everything except for the vertical asymptote. There's everything except for the horizontal. I'm happy with that. We know that. What's the domain and range going to be for the inverse? That's it, right? You have to change x and y so that it represents, but that's it. Suppose these two things intersect at 0, 0, and another point. Use the calculator to find the coordinates of that other point. I don't think you really need the calculator to do that. How would you do this? By hand algebraically. You set them equal to each other and solve for x. Right? That's all you have to do. Or you could graph the two and use the intersect command. Do I need to go over how to use your calculator to find the intersect command from a graph? Should be easy, right? You do that a bunch. And then it wants the equation of the line that passes through 0, 0, and a. I know it's going to be that since the y-intercept is 0. It's going to be some constant times x. Whatever that constant is, it's just this, should just be, if this is like the point AB, and this would just be like B over A. The slope from 0, 0 to AB is just going to be B minus 0 over A minus 0. Anyway, that's the gist of it. On your assignment for Chapter 2, I'm just going to ask you to do the Chapter 2 review rather than all the section problems. I feel like this is review enough to where one section of review is fine. What I'm passing out to you right now is the quiz for Chapter 2. This is take home. It should be turned in next class whenever that happens to meet. Everybody's okay so far? Also, next class will be the Chapter 2 test. Did everybody hear that? Yeah. The Chapter 2 test will essentially be the same as the quiz I just handed to you, except the test also includes topics inverses. There's no inverses on this. That's like section 2, 3 from the text. The test will also have inverse questions on it. That is next class.
You're going to test next class?
Yes.
This isn't that hard.
It isn't that hard.
This is like algebra.
This is all stuff you've done multiple times before. So we are just taking one day, doing some examples. Here's a bunch of stuff we're taking a test tomorrow. You should know how to do this.
You got it.
You got it.
The game, are you sure?
Come back.
Yeah.
She wanted starts now.
I found it myself the other day.
Second semester.
Sam, come here.